Hi everybody, this video is going to continue on with lesson 3.1. It's just that now we're talking about graphing and we're also talking about shading. So here we're talking about inequalities. So remember the rule, when you have an equal sign, you make a solid line. When there's no equals with it, you make a dotted line. What that tells us is whether the points on the line are included in the solution or not. If it's solid, they are included in the solution. If it's dotted, they are not included in the solution. So here we have three lines, and we're going to graph them, and we're going to shade them. After we do the graphing and shading, we also have to find the vertices. And because of that, because we need to find the vertices, what I'm going to do is I'm going to label my equations. So I'm going to call this R1, this R2, and this R3. R is standing for row. Row 1, row 2, and row 3. And so now I'm going to graph each of those equations. The first equation, x is less than or equal to 6. So is that going to be a horizontal line or a vertical line? Well, it is a vertical line, and it is solid. And then we have to decide our shading as well. On the shading, a couple things. Because we are doing so many lines, I would recommend using colored pencils. You don't have to, but it just might help. Also, as we shade, I would say don't shade very darkly. As we start out, we're going to shade kind of lightly, and then later we will get dark when we decide what the final area is. But like if you go in there with a black Sharpie and shade it, you're not going to be able to see where the overlap is. So I'm going to start out lightly so I can see the overlap. Now this says less than or equal to. The equal to is accounted for because it's a solid line. How about the less than? Well, doesn't it make sense that less than would be over this way? Right? This is less than, this is the less than part of it. In addition, the line, the arrow is pointing. Okay, let's look at the next one. Let me tell you that the way we graph this next line is we're going to do slope-intercept form. So we're going to start at the 1, go up 1, right 2. So starting at the 1, going up 1, right 2, I'm going to connect those with a line. It is a solid line because there is an equal sign. All right, let's talk about which way to shade. There's a couple of ways to decide which way to shade. One way, I'm a little bit reluctant to say it, but I'm going to say it anyway, is if it is in y equals form, then you can use this method. If it's not in y equals form, you can't use this method. But if it's in y equals form, we can just say, well, less than means underneath, right? It's lower, so it's going to be less than. So we're going to shade over here. Now, I shaded the whole thing, but in reality, we don't really need to shade this part. And the reason we don't is we already know it stops at that red line, so we don't have to shade over there. But we are going to shade here. Once again, the bottom line, it can be done with y equals mx plus b, slope-intercept form. So it starts at the 4, goes down to right 1. Okay, so here's my line, down to right 1. I need to connect them with a line. It is solid. So here is that line. I need to decide my shading. Okay, do you remember I said there's a couple ways to do it? On this middle row, row 2, I went below because it was less than. You're always thinking about below and above because it's a y. We're talking about like on the y-axis. So with this blue line, this middle line, I started here and I went on the y-axis. That's below. Similarly, this time it says above, but I go to the y-axis and I go above. So it's going to be shaded up here. But once again, I don't need to shade anywhere except inside this triangle area. I want to get back to that shading. That's the most confusing part to a lot of people. And so let me tell you the other method, and the other method is to pick a test point. We typically pick the test point of 0, 0. Why? Because it's easy. So let's look at this last row, this green one again, and test the point 0, 0, and I'll show you what I mean. So I take that equation and I plug in a 0 and I test it, and I'm asking myself a question. I'm saying, is 0 greater than all this? So I'm going to work it out just so I can make sense of it. That's 0 plus 4, that's 0. Is 0 greater than 4? No, it's not. If it's not, then I go over to my graph and I find the 0, 0, and I say, don't shade over here, because the answer was no. So don't shade over here, go to the other side and shade the other side instead. That's the test point method. I'm going to do that also with that middle row because I think it's an important method for you to understand. Okay, so I'm going to test it in that middle row. I'm going to plug in my zeros, and when I work it out, I get 0 is less than 1. Yes, 0 is less than 1. So again, I go to my test point, that's 0, 0, and I shade on that side of the line, the 0, 0 side, because the answer was yes, so I shade on that side. That is our method for shading, which way to shade. Okay, the next thing that we need to do is we need to look for where are the vertices of this triangle, because that's what it says, find the vertices. I've just highlighted them so we can see exactly what we're talking about. Some of the vertices they'll be easy to find. You can see it with your eyes. Some of them you can't. But on this one, there are 2 of these that we can see with our eyes, and the other one we can't, so we'll talk about that. But I can tell right here what this vertex is, can't you? This is at, looks like 6, 5, right? Sorry, I mean 6, 4. Also, the one down here, I can see it with my eyes. It is at the point 6, 8, 6, negative 8. Now, I'm going to go back a step, because remember how I labeled these? There was a reason I labeled them. I'm going to put them up here. This is row 1. This one was row 2. And this one was row 3. Because whatever points we come up with, so I came up with 6, 4, and I came up with 6, negative 8. Okay, 6, 4 is at the intersection of R1 and R2. What that means is it should work in both R1 and R2. So I'm going to go over to R1, and when I check it, I'm actually checking the line itself, not the less than part, just the line. So I'm going to put it in here and pretend like it's an equal sign, and X is 6. Okay, good, easy. That's also why X is 6 here, is because it's hitting R1. And so X is 6. We need to look at the Y value. For the Y value, I have a 4. That should work in both R1 and R2. Well, R1 doesn't even have a Y, so let's forget that. But R2, 4 should work as a Y in there. In fact, 6, 4 should work as a coordinate. So if we plug this in, I'm going to come over here, R2. If I plug in y equals, I'm going to change that to 4 equals 1/2 of 6 plus 1. I made it equals because it's the line that we are talking about, not the shading. And so this is 3 plus 1. Yes, it does work. That's how I check that answer. It does work. R3. I'm going to take R3, and I'm also going to check it with 6, negative 8. So I plug it in, I get negative 8, I'm plugging in here. Negative 8 is equal to negative 2 times 6 plus 4. That's negative 12 plus 4. Yes, that does work. So I've confirmed that both of those answers work. Now, the mystery is, what about this point over here? I could make a guess, and I could say, well, it looks like it's at about 1.3, and no, you can't do that. You can't make a guess. You have to actually find the answer. How? How do we find that answer? Well, we look at the ones that we're talking about here. These two, that's the intersection of R2 and R3. So I need to decide where do they intersect? Well, I'm going to have to look at R2 and R3, and I'm going to have to solve it. How do we solve this? How do we do that? It's a system of equations. Oh, it's a system of equations. And once again, we're looking at the equals part, not the less than or greater than part. So, because they both equal y, I'm going to use substitution method. and I'm going to set each 1/2 x plus 1 equal to negative 2x plus 4. I took this y, I plugged it in over there. I need to solve this. Personally, I like to get rid of fractions first, but I'm going to hold off on that. Maybe I'll combine my terms. I'm going to subtract 1 from both sides. That's easy. Okay, I still have that fraction I need to deal with. You have a couple of options. If you're okay with fractions, you can just add 2 to both sides. But I don't want a mixed number. If you're not okay with fractions, then the best thing to do is multiply by the denominator. I'm going to do that. I'm going to multiply times 2. Because that's just going to get rid of the fraction, make my life easier. That's a lot easier to deal with, right? So I'm going to add that 4 to the other side, and I get 5x is equal to 6. I get x is equal to 6/5. Now, was I ever going to guess with my eyes that that's where that hit? No, I was not. I mean, let's be honest, I'm not going to get there. So I've got my x value. I now need to find the y value. I'm sticking with R2 and R3. I need to plug this into one of them, does not matter which one, and see what comes out. Well, R2 already has a fraction in it. This is another fraction. Let's avoid that, shouldn't we? Let's do R3 instead. Once again, I'm doing equals because it's not the shading part, it's the equals part is the line. So I'm going to multiply this out. I have it in a fraction. I need to put this as a fraction. That's 20 over 5. That is 8/5 for my y. So my intersection point of R2 and R3 is at 6/5, 8/5. Okay, so there's a lot of things here. Some of it is review, some of it's new. You knew how to graph lines. You've probably done some shading before, but it's been a while. Finding those pesky ones that don't match up, that's kind of new and bothersome, right? But it's what we have to do. It's part of the whole meaning of this whole unit. Okay, I'm going to stop there for this video. I will probably make another video to do the other one if you want to see that. Otherwise, if you feel like you've got a good handle on this, then you're done with this one as well. We will talk about this when we come to class next time, and we'll do some examples together as well.